Hey class, Mr. Bean here, and we're going to be talking about video 46, power. All right, so I'll let you read what the conceptual understanding is of power right here as definition, and I'm going to show you the formulas in which you can discuss or describe power. Now it is down here, but I just want to throw it up here as well. So we'll use P for power. And power is the rate at which work is completed. Okay, rate at which work is done, or the rate at which energy is delivered, or the rate at which rate at which work is done is the common definition of power. So we have your work over time. Okay. Okay. So work, we could describe it as force times delta x, right? And we're going to assume here that it's going to be like the cosine of 0. Okay. And here we'll have t. Okay. So usually it's parallel direction. Okay. We'll assume it's cosine of 0. So if you have force times delta x over t, you have power. Okay, now sometimes you can look at this part right here and we see we have delta x over t. So we can further describe it as force times the average velocity. Okay, and so all of these are acceptable equations for power. Now the units are just going to be joules over seconds. So joules per seconds has a unique SI unit called watt or watts. Okay, all right. So go ahead and look at this here, and we'll go ahead and talk a little bit about some problems here. Okay, so here is 5.12. We'll let you go ahead and look at that and apply the definition or the formula for power and go ahead and try to solve 5.12. Okay, all right, and also go ahead and work on 5.13 as well. Okay. All right, so go ahead and read this paragraph right here. And we talked a little bit about this, but again, it's talking about another way to describe power is force times average velocity. Okay, so here is 5.14. So go ahead and look at this here and try to answer 5.14. Okay. Here is 5.15, and here's the answer for you. Let's just kind of work through this. It says a 70 kilogram cyclist develops 210 watts of power while pedaling at a constant velocity of 7 meters per second. What average force is exerted eastward on the bicycle to maintain this constant speed? So here's the formula. Power is equal to force times velocity. And we can solve for force and have power divided by velocity. And it's a pretty simple calculation here to get 30 newtons. Okay. All right. So here is 5.16. So go ahead and take a look at this one here and try to answer 5.16. We'll hit pause. Okay, here is 5.17. We'll let you take a look at 5.17 here and go ahead and answer that. We'll hit pause. Okay, here is 5.18. Go ahead and answer this and we'll hit pause. Okay, and here is 5.19. Okay, which of the following are appropriate units for power? Choose all that apply. Okay, so I'll kind of give you a hint here. Well, clearly this one here is one of them, joules per second. Okay, now off to the side here, I'm going to help you out a little bit. So here we have joules per second, right? Okay, now that's also, now joules is also Newton times meters over seconds, right? And newtons, right? Newtons is kilograms, meters, over seconds, and we still have meters over seconds over here. So you can see here that we could have kilograms, meters squared over seconds squared. All right, so using this here, kind of see which answers might apply over here as well. Okay. Uh, so joules per second. Oh, oh, kilograms, meters per second squared. Ooh, hold on. There should be seconds squared here. Okay, and then this should be seconds cubed. All right, be careful. Okay, watch out. My bad. Okay. All right. So here is 5.2, last one in this section here. A box of mass m is pushed up a ramp at constant velocity to a maximum height h in time t by force F. The ramp makes an angle theta with the horizontal as shown in the diagram. Okay. What is the power supplied by the force? Okay. Choose all that apply. Okay. All right. So a couple of things here, some trig here I want to just talk a little bit about here. Maybe this might help you out here. So let's go ahead and talk about this here. So here's a ramp here, right? And we'll call this here maybe this is h here, right? And this is distance d here, for example. And here is theta. Okay. All right. So now the sine of theta, let's take a look. This is important here. The sine of theta is going to equal, right? Sine of theta is going to equal, well, it's a side opposite over the hypotenuse. So it could be expressed as h over d, like so. Okay. All right. So that means that from here, we have some things here. We can say that h, the height, is also equal to d sine of theta, like so. Okay. Or we could say that d is equal to h divided by the sine of theta. Okay. So power, right, is work divided by time. Okay. And work is a force times, we'll say distance here. Okay. We'll say distance here and, and over time here, like so. All right, so take a look at this and take a look at over here and see what answers might fall out of here. Okay, and that will conclude this short video number 46 on power.